Let's work a couple more examples looking at balancing chemical reactions. The hard part of balancing chemical reactions isn't always the balancing itself, but often identifying what the compounds are. I am more likely to give you the chemical formula or chemical names than I am to give you chemical formulas. So you need to be able to get those names into formulas to be able to balance this correctly. So let's see what we've got here. Calcium nitrate decomposes on heating, producing calcium oxide and gaseous nitrogen and oxygen. Write the balanced equation for this reaction. What is the coefficient of oxygen and gas when this equation is balanced using the smallest whole number coefficients? First up is calcium nitrate. I know calcium. Calcium is one of my alkaline earth metals. It's in group 2, and group 2 always forms +2 charges on their ions. I know nitrate. It's one of my polyatomics I have memorized. Nitrate is NO3 minus. It only has a -1 charge, not a 2 negative. I apologize for that. I was thinking about calcium in that moment. So I have calcium 2 plus and nitrate, which has a -1 charge. In order to get this to balance, I'm going to need 2 nitrates for every 1 calcium. I realize it doesn't say it specifically in this question, so I would not expect you to be able to identify this without further information, but this will be a solid when I'm starting the decomposition process. It's the only reactant I have. I know that because it doesn't talk about it reacting with anything. It just says it's decomposing on heating. The little triangle here just means heating. And this is going to produce calcium oxide. Okay, so again, I know calcium. We just talked about it. It's an alkaline earth metal. Alkaline earth metals in their ionic form a +2 charge. And then oxide stands for oxygen in its anionic form. So it's an ion, but it's an anion because it gained 2 electrons. Oxygen's in group 16. It wants to gain 2 electrons, so O2 minus. So that will form, excuse me, CaO. That will also be a solid. And then gaseous nitrogen. Remember, nitrogen is one of your diatomics, so N2, and oxygen, O2. Now, you've got calcium, nitrogen, oxygen, calcium, nitrogen, and oxygen. I've got 1 calcium. Remember that this 2 applies to the entire thing here. So overall, 2 nitrogens and 6 oxygens to start. And on the product side, I have 1 calcium. I have 1 oxygen in my calcium oxide, 2 nitrogens, and then 2 more oxygens for overall 3. Now it looks like it might be pretty easy to balance. You're like, oh, well, 6 oxygen, 3 oxygen, just double the oxygen. But your oxygen is split across 2 compounds. I can't just double it. It doesn't work that way. Let's go ahead and put a 2 in front of this calcium oxide. Okay? Let's just say I just double that. That gives me now 2 plus 2, or overall 4 oxygen. Assuming I could just double my other oxygen, 2 plus 4 giving me 6. This is what a lot of students want to do. But don't forget that when you put the 2 up front here, you also affected your calcium here. Now this calcium has a 2. So this calcium needs a 2. When I put the 2 in front of this calcium, though, it messes up my nitrogens and my oxygens on the reactant side. So now instead of just 2 nitrogen, I have 2 calcium nitrates. So I have 2 times 2. Overall, 4 nitrogens. I have my original 6 oxygens, but I have 2 of that entire compound. So 6 times 2, I have overall 12 oxygens now. So my calciums are balanced, but my nitrogens are no longer balanced. I can go ahead and multiply this by 2, giving me a 4. That's balanced. But my oxygens are not. I need 12 oxygens. Right now, as written right now, I only have 2 plus 2, I only have 4. But I can make this into my 10 oxygens I need to get my overall 12. So the coefficient, that number I'm looking for right there, is a 5. The smallest whole number coefficient on oxygen is going to be a 5. And our other question in this module, referencing the following balanced equation, which statement is incorrect? The reaction shows me a balanced reaction here, where I've got aluminum solid reacting with hydrochloric acid to form aluminum chloride and hydrogen gas. So I've got five options here, A, B, C, D, and E. And it could be E, but it's probably not going to be E. Okay, only go to E if you're sure without doubt that the other answers are not correct. So first up, the production of 2 moles of aluminum chloride consumes 6 moles of HCl. That is completely truthful. That is correct. For every 2 moles of aluminum chloride produced, 6 moles of HCl is consumed. So can't be that one because that's not incorrect. 2 moles of aluminum metal, 2 moles of aluminum metal produces 3 moles of molecular hydrogen. Also correct. Molecular hydrogen is another word for H2. So that's not it either. 2 moles of aluminum metal, okay, reacts with 6 moles of hydrochloric acid. Also correct. 2 moles of aluminum metal reacts with 3 moles of molecular oxygen. Oh, no, no. 2 moles of aluminum produces 3 moles of molecular oxygen. And if you're paying attention, just by process of elimination, you should be able to tell that one of these two is incorrect because they're doing the opposite thing. So the incorrect statement here is D. 2 moles of aluminum metal does not react with 3 moles of molecular hydrogen. It produces 3 moles of molecular hydrogen.